Random Forest Classifier Tutorial: How to use tree-based algorithms for machine learning. Tree-based algorithms are popular machine learning methods used to solve supervised learning problems. These algorithms are flexible and can solve any kind of problem at hand, classification or regression. Tree-based algorithms tend to use the mean for continuous features or mode for categorical features when making predictions on training samples in the regions they belong to. They also produce predictions with high accuracy, stability, and ease of interpretation. So every data scientist should learn these algorithms and use them in their machine learning projects. In this article, you will learn more about the random forest algorithm. After completing this article, you should be proficient at using the random forest algorithm to solve and build predictive models for classification problems with scikit-learn. Random forest is one of the most popular tree-based supervised learning algorithms. It is also the most flexible and easy to use. The algorithm can be used to solve both classification and regression problems. Random forest tends to combine hundreds of decision trees and then trains each decision tree on a different sample of the observations. The final predictions of the random forest are made by averaging the predictions of each individual tree. The benefits of random forests are numerous. The individual decision trees tend to overfit to the training data, but random forest can mitigate that issue by averaging the prediction results from different trees. This gives random forests a higher predictive accuracy than a single decision tree. The random forest algorithm can also help you to find features that are important in your dataset. It lies at the base of the Baruto algorithm, which selects important features in a dataset. Random forest has been used in a variety of applications. For example, to provide recommendations of different products to customers in e-commerce. In medicine, a random forest algorithm can be used to identify the patient's disease by analyzing the patient's medical record. Also in the banking sector, it can be used to easily determine whether the customer is fraudulent or legitimate. Step 2, the algorithm will create a decision tree for each sample selected. Then it will get a prediction result from each decision tree created. Step 3, voting will then be performed for every predicted result. For a classification problem, it will use mode, and for a regression problem, it will use mean. Step 4, and finally, the algorithm will select the most voted prediction result as the final prediction. Now that you know the ins and outs of the random forest algorithm, let's build a random forest classifier. We will build a random forest classifier using the Pima Indians diabetes dataset. The Pima Indians diabetes dataset involves predicting the onset of diabetes within 5 years based on provided medical details. This is a binary classification problem. Our task is to analyze and create a model on the Pima Indian diabetes dataset to predict if a particular patient is at a risk of developing diabetes. Given other independent factors, we will start by importing important packages that we will use to load the dataset and create a random forest classifier. We will use the scikit-learn library to load and use the random forest algorithm. Data equals pd read csv /data /pima_indians_diabetes.csv. Now we can observe the sample of the dataset. In this dataset, there are 8 input features and 1 output target feature. Missing values are believed to be encoded with 0 values. The meaning of the variable names are as follows, from the first to the last feature. Then we split the dataset into independent features and target feature. Our target feature for this dataset is called class. Before we create a model, we need to standardize our independent features by using the standard scalar method from scikit-learn. X scaled equals scalar.fit transform x. You can learn more on how and why to standardize your data from this article by clicking here. We now split our processed dataset into training and test data. The test data will be 10% of the entire processed dataset. Now is time to create our random forest classifier and then train it on the train set. We will also pass the number of trees 100 in the forest we want to use through the parameter called n-estimators. The above output shows different parameter values of the random forest classifier used during the training process on the trained data. ypred equals classifier, predict x test, then we check the accuracy using actual and predicted values from the test data. As I said before, We can also check the important features by using the feature importances variable from the random forest algorithm in scikit-learn. The figure above shows the relative importance of features and the contribution to the model. We can also visualize these features and the scores using the Seaborn and Matplotlib libraries. From the figure above, you can see the triceps skinfold thickness feature has low importance and does not contribute much to the prediction. This means that we can remove this feature and train our random forest classifier again and then see if it can improve its performance on the test data. We will train the random forest algorithm with the selected processed features from our dataset. Perform predictions. And then find the accuracy of the model. Now the model accuracy has increased from 80.5% to 81.8% after we removed the least important feature called triceps skinfold thickness. This suggests that it is very important to check important features and see if you can remove the least important features to increase your model's performance. Tree-based algorithms are really important for every data scientist to learn. In this article, you've learned the basics of tree-based algorithms and how to create a classification model by using the random forest algorithm. You can download the dataset and notebook used in this article here. If you learned something new or enjoyed reading this article, please share it so that others can see it. Until then, see you in the next post. I can also be reached on Twitter at Davis_McDavid. Data scientist, AI practitioner and trainer, software developer, giving talks. Teaching, writing, author at FreeCodecamp News. Reach out to me via Twitter at Davis_McDavid. Learn to code for free. FreeCodecamp's open source curriculum has helped more than 40,000 people get jobs as text source, freecodecamp.org.